Well, welcome everyone. It's June 13th, 2023. This is our first millimeter wave meter discussion, and got the millimeter wave out to a few testers and just looking for feedback from them. And we have Oram Miller here, who's our resident building biology 5G guy, and he's done a lot of research on it and understands us fairly well. Myself, Rob Metzinger of Safe Living Technologies. We have Bruce Hildesheim, who is part of our group that builds and part of our team that builds the meters for us and designs them. So he's graciously offered to join the meetings as well. We have Tony, our sales and marketing manager at Safe Living Technologies, Kevin and Zach, our technicians at Safe Living Technologies, Peter Sirik, a tester out in San Diego, and Tyler is one of our other techs as well too. We're currently working on two meters. One is the new RF meter, the millimeter wave meter, and we also have an electric and magnetic field meter with body voltage as well too. So we'll talk a little bit about that as well, but primarily the millimeter wave meter here. So first of all, we have this introductory video that I'm going to play quickly here. It's just a couple minutes just to give you a general introduction, and then we'll get into more depth about the meter itself.
The new Safe and Sound Pro millimeter wave meter is the first consumer level 5G millimeter wave meter. This meter measures high-band 5G signals between 24 to 40 gigahertz and comes with multiple accessory options for more detailed readings. These options include a horn antenna, a stub antenna, and an attenuator for various uses. To start the unit, press and hold the power button. After that, your battery level will appear on the screen. The mode and max reset button will allow you to capture your maximum values of RF exposure. Now you can attach your desired antenna. To start, we will be using the stub antenna. The stub antenna is ideal for most uses. It has about 50 degrees of coverage in the front and back. It is suggested to slowly move the meter around in a figure-8 motion while in use. The horn antenna is great for more directional measurements. It has about 35 degrees of coverage in the front. Finally, the attenuator is ideal for when your RF readings are maxing out the device. If this happens and the attenuator is not installed, the meter will display a brief message and automatically shut off. When the attenuator is attached, it will display the readings as 100 times weaker, so you are able to measure at higher power levels. When measuring RF sources using the attenuator, ensure you multiply the value by 100 to attain the correct reading. Overall, the Safe and Sound Pro millimeter wave meter is the perfect partner to the Safe and Sound Pro 2, our low and mid-band 5G meter. For more information on the new Safe and Sound Pro millimeter wave meter, the Safe and Sound Pro 2, and other EMF mitigation products, please visit our website at www.safelivingtechnologies.com.
So that link is on our website. If you ever want to review it or send it to anybody, it's up there. Just gives you a general description of how the meter works. So just some background about some of the challenges we had putting this meter together. So I think we're about 8 months at this point in time of development and scheduled to release on June 30th, 2023. So just a few weeks away here, which we're very excited about. And, getting a stable response required additional R&D to get it to desired building biology specs. So we had a meter that would measure really well down to about 100 microwatts per square meter, but we wanted to get down to 0.5 or under 1 microwatts per square meter. So I was pushing Bruce and the guys to get to that point, and they magnificently did that. So it took additional time for that, and we didn't want to compromise any of the specs or the pricing because the horn antennas were hugely expensive, so I had to figure out what to do with the horn antennas and had to design our own basically. So that was tough. And the battery power usage is very high in these meters as well. So I think we got about 3 hours on it. That's magnificent compared to how much power this thing uses. So the guys really did a great job on that. And the horn antenna there, and the sensitivity was key too. So we wanted something below 1 microwatt per square meter for building biology, and that was probably one of our biggest challenges there, getting it down to that level. That's why it took a few extra months to get to that point. So yeah, we know other companies that have tried this and for a few years of development have not made it through it. So I can understand their frustration and what they had to go through to get to this point. It was very challenging. Parts are expensive, and with any electronics, they're hard to source too these days. And one of the other challenges too is how do you test this stuff? So if you have a meter, you got to fire a signal at it and you got to read it. But third-party testing facilities are very expensive, and we found they didn't have adequate equipment to for our testing needs. So I went to several of them in the province of Ontario here, and none of them had the testing methodology, and very few had the testing equipment that went along with it. So that was one of the challenges too. So we purchased our own signal generators, power meters, spectrum analyzers from 1 meg to 40 gig, and constructed a full anechoic chamber. We can test around 700 megahertz to infinity, basically. It's a full anechoic chamber with ceilings, walls, and floors lined with these tiles. So it turns out very handy. Whenever you make a change, you can just go into the chamber and do the tests. So that's another bonus that actually helped us. You know, we'd be a lot longer if we had to go to a test facility to do any changes or to test changes. We were able to do it right at home, right at our shop. So that was a bonus as well. So looking at the Safe and Sound Pro, the frequency range, as we stated before, is 24 gig to 40 gigahertz. It's a high band RF meter. And in the USA, we cover 28 gig, 39 gig with 5G millimeter wave bands. And it's live in major cities, particularly Verizon, AT&T, and T-Mobile. Oram will fill us in a little bit more about those details, I'm sure, when he's up. Canada, we're going to cover 26, 28, and 38 gig as well. So same band, but it's not live right now at this point. Spectrum auction is planned for 2024, but we're still picking up things in the streets. Could it be possibly test sites? Could it be vehicles? That's what we're going to discuss later in this call. So why are they called millimeter waves? Is because their wavelengths are under 1 centimeter. The industry calls it ultra wide service, a UW. So rough cost, the base model is $849, and then there's some accessories that go on to that, and you can click on this link to see what the accessories are as well. And basically, it's the horn and the attenuator. So those are your choices. So it detects and measures 5G, 24 to 40 gig. Common sources in this range are 5G cell towers, 5G cell phones. There's some radar, other 5G high band devices, and automobile radar is what we're finding as well. So it's built in North America. It's consumer level RF meter, probably the first of its kind in North America. And it's accurate and affordable. It's a fraction of the cost of the higher end band detectors. Perfect companion for the Safe and Sound Pro 2. The digital display displays in microwatts per square meter. It does peak, it does average, and it's a direct comparison to building biology guidelines with the peak. We have the peak hold feature, and sampling rate is 5 microseconds, just like the Safe and Sound Pro 2. So it's very similar to operating as the Safe and Sound Pro 2, which people were comfortable with. So we tried to do that as well. It also has an audio feature with 3 different sound levels. Currently, we're playing with the audio levels and trying to get that to the ideal level here.
Companies in the United States that have 5G service in the low band, mid band, and high band, and that would be, as you have mentioned, Verizon, T-Mobile, and AT&T. But there's a fourth one. When T-Mobile was allowed by the Federal Communications Commission or the Federal Trade Commission here in the United States to absorb and merge with Sprint in 2020, the government only allowed that if a fourth company took the place of Sprint. So that's Dish, and they have been expanding their customer base So you can add the name Dish to your list of U.S. Cell companies. Now there's U.S. Cellular also, which is in the Midwest and a couple of states in the Atlantic seaboard, but it's not nationwide, whereas Dish is nationwide. And they are a pure 5G company from the ground up. They just, all of their equipment is 5G, not necessarily millimeter wave. I don't know about low band, but definitely in the mid band. They've been competing with the other three companies at auctions to get especially the C-band between 3.5 and 3.7 gigahertz, and Citizens Broadcast Radio Service, CBRS, which is coming out soon, in the 3.4 to 3.5 gigahertz range, all in the mid-band. So they've been competing with the other three companies for spectrum in each U.S. city, wherever they want to have deploy their services. I saw some Dish antennas on the roof of the apartment building I went to yesterday, which haven't been turned on yet. So it's all 5G, which means that there's no 4G equipment in there. There's no non-standalone transmitters. Everything is standalone in terms of the way the signal is processed by the radio that's right behind the antenna. Massive MIMO, carrier aggregation, 256 quadrangle amplitude modulation, or QAM. All of these features that I talk about in my 5G article that I've learned going to the 5G conference, Mobile World Congress conference here in Los Angeles, which has now been moved to Los Angeles, and the webinars I've taken and the articles I've read. I know all the 5G technology, and that's all being used by Dish from the ground up.
So some of the specifications, so we have the LEDs on it, like the Safe and Sound Classic and Safe and Sound Pro 2. The different LEDs flash and light up at different levels, as you can see on the right with the table. And yeah, very, very quick visual. If you're in the green, if you're in slight, you're in a good spot. If you're in the extreme in red, it's a bad spot. So very easy for anybody to use this meter just by looking at those LEDs if they don't want to analyze the data and the numbers. So let's talk about that stub antenna. We call it a little stub antenna. It's an omnidirectional, it's a quasi-omnidirectional antenna, and frequency response 24 to 40. We're actually finding it's effective down lower than that. We just found last week when we did some testing, it went down to about 18 gig. And so it gives us some extra range on the bottom end there. We'll do some more testing and figure that out exactly. And we didn't lose a lot of tolerance when we went down that far. I think it was down to maybe plus or minus 7 or 7.5 dB, something like that. And with this antenna, the minimum measurement signal you can measure is 5 microwatts per square meter. So we thought that was pretty good for a basic stub antenna. The maximum measurable signal is 500,000 microwatts per square meter, or when you stick the attenuator on, you can get to 50 million microwatts per square meter. So we're definitely in the thermal levels here when we're measuring with that. So the reception pattern, it's quasi-omnidirectional, as I said, so 50 degrees to the front, 50 degrees to the back. I've got a picture of that in the coming slide. Horn antenna, it's directional, not omnidirectional. Same frequency response and tolerance. Minimum measurable signal is 0.5 microwatts per square meter, so very low, very sensitive meter. We're very pleased and happy with that. The maximum measurable signal is 30,000, or with the attenuator 3 million, and that should measure most signals that we're searching for. Even without using the attenuator, we're finding the signal strength is a lot lower on a lot of these signals we're measuring. So we'll just have to see how that goes as the meter gets distributed out there, and how often the attenuator is necessary. We're still kind of learning on that. So it is a directional reception pattern, 35 degrees to the front. And here's some kind of crude pictures of what the reception pattern looks like. So on the left side with the horn, we can see this 35 degrees coming out the front here, roughly. I tried to draw it in a little bit of perspective, but that's what we're looking at. We'll have better pictures for that in the future. And so then 50 degrees front and back with the Omni. So it misses what's at the side. So basically you'll have to rotate this thing left and right in order to pick that up. And it's gonna yield higher readings than the horn itself too. So just because it's getting multiple directions, and these signals are highly reflective too, so they're coming from all directions. Yeah, this will gather up more than the horn will. The horn is for pinpointing sources, basically. That's what we're looking at there. And then we have the attenuator. So it's a minus 20 dB attenuator, or 100 times signal reducer is what you could call it. It covers the same frequency range. It doesn't alter the readings that much, plus or minus maybe a half or 1 dB, somewhere in that range, I'm thinking. And it gets inserted between the antenna, whether it's the stub or the horn, and the meter itself. So this, when you look at the display, you would have to take the reading on a display and multiply the reading by 100 to get the true value. If you have the attenuator in, we didn't allow for an automatic conversion on the meter. We just thought that people could do this themselves. It just simplifies things with the meter for us as well. So it allows the meter to display 100 times higher power density signals, and it can get up to 50 million microwatts per square meter with the stub and the fixed attenuator. So that's, hopefully we don't get exposed to that. That's pretty high. The range, well, that's with the stub, and yeah, with the range of the directional antenna of the horn, that's this one, it would be up to 3 million microwatts per square meter. So that's still pretty decent power levels. And so the attenuator, there's when you're using these devices, there is the RF chip can get overexposed to RF and heat up. If we get higher levels of RF that we're in, and they exceed a certain value for a long period of time, it can burn up the RF chip inside. So we built in power overload protection. So
okay.
Yeah, it's susceptible to damage if you're at continuous high levels of RF. And overload protection is activated when the following power densities levels are exceeded. So if the stub goes over 500,000 for a sustained period of time, about 3 seconds, the meter will display maximum power level reached or something to that effect, and it'll say, please attach attenuator, and it will shut down.
Okay.
So it'll take itself out of risk mode and turn itself off if it's exposed to high power levels. So when we have the horn on, it's over 30,000. If it hits over 30,000 microwatts per square meter for more than 3 seconds, same thing. It'll shut down and tell you to, or ask you to install the attenuator if you want to continue measuring those levels. So we think that'll keep the meter safe, and it's necessary actually to do that with this RF equipment. So, yep, basically, install the attenuator if you're reading higher power levels. The meter will tell you that and walk you through that. So this is what it looks like at startup. There's a self-calibration that happens. It'll show battery life, and it can run continually if plugged into the USB port. So this is basically the startup screen. And if you're plugged into USB, this will say USB instead of battery here as well, just like the Safe and Sound Pro 2. The second screen that comes up is select your antenna type. So you can select it via the mode switch, which is this bottom right-hand corner switch here. You can toggle it basically up and down. So by pressing this mode button, you'll see it'll either select the stub or select the horn. This arrow will just bounce up and down here and toggle when you press the mode button. And when you have your selection at what you'd like, then you press and hold the mode switch for 3 seconds. And that selects your desired antenna, and I believe it saves that, so the next time you turn it on, it's set to that value as well. So looking at the display screen, the first line, it'll actually have a bar graph of the intensity that'll pulse back and forth, just like the Pro 2. We're at a very low reading here, so we don't have anything pulsing at this point on the screen. And we do peak max, and we do average, just like the Safe and Sound Pro 2 as well. Headphone jacks on the top of the meter as opposed to the side of the meter. And at this point, 3.5 millimeter. The speaker sound has 3 levels. This switch, it's a dual switch, switches between power and volume or speaker on, speaker off. And we have our USB port for continuous power. No data at this point. We are looking at data in the future. Then we have the mode and max reset button. So this button allows you to select antennas as well as reset the max value for the reading on the display. So very similar to the Pro 2 as well.
So Rob hasn't seen one of these yet. The new horn antennas that will be in production are actually plated. They're electroplated rather than the variability of paint. So this is copper and then nickel plated on top. So this gives us a way more consistent performance than we've ever had before. The first 5 production units that I tested, all in the lab, are within a plus and minus half dB of each other. It's amazingly consistent. So the other thing, Rob you guys probably know, but the stubby antennas, there's one side that has an SLT logo.
Yeah.
I don't know if you can see it on one side that doesn't. So our testing is the SLT logo facing you. In other words, the best lobe of the antenna, you could say that it's like a figure 8, but the biggest lobe of the figure 8 is facing forward on the flat side of the antenna. And so when you install the stubby antenna, you want to have the SLT logo towards you.
Mm-hmm.
Okay. And what you guys have found is what would be expected, because the millimeter waves are bouncing off all directions. In many cases, the stubby antenna will pick up a lot, a higher reading. We'll be doing a detailed radiation pattern of this thing. It just, I've done some basic tests, a month or so ago. So it's not like it doesn't pick up anything from the side. It's just probably in the order of 15 dB, sometimes maybe 20, 30 dB down. But there are some side lobes that can happen. The horn antenna is designed for specifically really narrowing where these sources come. When we're saying over 30 degree or somewhere around 30 degree beam width, that's a very narrow, it's like plus and minus 15 dB beam width. Okay, so that's for narrowing in on sources. And so it's interesting, the performance of these RF modules. When Rob was mentioning the protection for the RF detector, the RF modules that we designed that are in the meters, they actually have 3 chips inside, RF chips, that are all equally vulnerable. And so that's part of the reason that this meter is so expensive. And so our protection is to protect the 3 chips inside this RF module. And that's what makes the heart of the meter. This is what makes the meter so expensive, the amount of R&D for that. Let's see, the other note, battery life, Rob, just a correction, we're going to see greater than 6 hours continuous operation with this. And that was power supply optimizations. I did a battery rundown before we did final tweaks, and it was an easy 7.5 hours with these Fujitsu batteries. With sound on max volume. The Safe and Sound Pro 2, for example, the audio output is a significant portion of the power consumption, whereas the millimeter wave meter, most of what sucks the power of the batteries on the millimeter wave meter is the RF amplifiers and detector. And so having the volume at maximum during our rundown tests is almost insignificant for battery life. The millimeter wave, Safe and Sound millimeter wave, is just fantastic because we don't really have to run into that issue.
You also have the USB connector to connect it to power continuously if you want as well too, right?
Right, exactly. So one thing with you probably noticed with the millimeter wave meter, that thing does not detect anything unless it's in the millimeter wave meter. Like the Safe and Sound Pro 2, if you have a power tool or something that emits electrical pulse, those pulses do have harmonics that go up into the microwave range, but you're not going to see pulses from power tools or electrical disturbances that are going to show up on the millimeter wave meter. So in other words, when you have that thing sitting in a home or wherever you are, powered by USB, and you come back hours later and you see that the max has not changed, you can be assured that there was no event that happened during that time. That meter is only going to detect millimeter wave stuff. So the existing material is internally, it's a 3D printed antenna, but the conductive coating is actually a conductive silver spray paint followed by conductive nickel spray paint. And what we've found is that it's very difficult to get a very consistent spray application surface density into the horn, because you can imagine that anything that gets sprayed in here will have a certain amount of blowback. Yeah. And so we're finding it challenging to get proper amount of vacuum without this connector installed. And so Brian, that's doing the manufacturing for our antennas, he suggested the idea of electroplating, and it's fantastic. So there is a slightly higher cost to that, but I think it'll even out because there's less labor involved in.
Okay. So the material of the antenna is a metal or is it plastic?
The core of the antenna is actually plastic, but it's
then it's coated.
It's coated. But interestingly enough, the weight now with this electroplating, I would be hard pressed just tapping it and everything like that. I would swear that this is an aluminum alloy or something like that. And really, this gives, obviously, I mean, I've got lab calibrated millimeter wave horns. This will compete with these things. The consistency that we're seeing in frequency response is on par with those. The other final thing with the stubby, Rob alluded to it. Performance is better than we expected. I'm pretty confident right now to say that we're going to see a 20 to 40 gig response plus or minus. I won't go on. I'm not going on a limb here, but tests in the last day or so, plus or minus 6 dB from 20 to 40 gigahertz with a stub antenna. Wow. It's unbelievable. It's So, anyway, sensitivity, fantastic. I know this has taken a long time to come out, and part of the reason is that just one of the reasons that I admired Gigahertz Solutions years ago is that their attention to detail, and this is actually lab calibrated equipment, and this is crossing the line between professional test equipment, which is very expensive. I mean, this unit could be better if we have temperature heaters, ovens inside here, temperature management, so that we can get a lower noise floor. There's all kinds of things that we can do, but we've had a lot of pressure to make something that's affordable.
I mean, the ease of operation of your meter, both of them. I presume that you also helped designed the Safe and Sound Pro in collaboration with Rob. So both of them are just really easy to use. So we'll be talking about that more in the coming minutes. But I also want to mention that the overload of the millimeter wave meter is not going to come ever from a transmitter. It's going to come from your phone having the 5G being turned on this and getting too close to that. That's where I did see a 500,000 once, but more like a 50,000 and 100,000 from this, like I do from when it's doing other activities in the low and mid band. That's where I saw the high power density levels, not from the antenna, but from my phone, being triggered by the antenna. So
Yeah. No, that's what we'll see, and as these units get out there. Yes, the other thing I forgot to mention, this RF connector here. Our plan initially was to have an internal antenna, but to make an antenna that's going to have a true frequency response that's consistent, that can be tested in labs, we had to have options for external, and then also to give us the option for direction finding with the horn. These antenna connectors, these 2.92 connectors, they're $30, $35 each, compared to an SMA connector, which you can get for, 50 cents or $1. All of a sudden, when we start getting, when you're talking about, consistent results above 24 gigahertz, costs go up. And so Rob's having to wrestle that, we're pushing and going, well, we need to have this connector in order to get this, but it raises the cost of the meter. So it's Anyway, it's exciting for me to see, after all this time, to see this thing come out. Sorry, you're not seeing a label on the front because I'm putting one on soon.
Thank you very much, Bruce. I mean, really, for all of this, you and Rob, you've added something that's really a great contribution to our efforts to clarify and help the EMF community understand this very difficult to understand concept of what is 5G.
Your time is precious, I know, and I thank you for all your comments that you've given us. I mean, just this guy is so knowledgeable, guys, that this is where I learn a lot of my stuff from. He's a great asset to have, and we'll try and have him in more meetings if he has the time to join us.
For more information on the new Safe and Sound Pro millimeter wave meter, the Safe and Sound Pro 2, and other EMF mitigation products, please visit our website at www.safelivingtechnologies.com.